Okay, so for the web work, let's look at number one. So as far as number one is concerned, we did two examples very similar to this in class on Wednesday. So if you were lost on this, then you didn't catch it, right? You didn't catch it, and then I posted the video. So, but we'll just get this one started because it's really important. It kind of lays the foundation for what these partial and multi-unit growth factors are. So if it triples every 5 hours. So you have 4 people who know it after 0 hours. Then how many people know it after 5 hours? If it's tripling every 5 hours. I didn't think that was a hard question. So every 5 hours, the number of people triples. So we start with 4 people, then 5 hours later, how many people will know the rumor?
12.
12. Maybe I didn't hear you. Okay. All right. Okay, so then 5 hours after that?
36.
And then 5 hours after that? Okay. So what growth factor do we have from that? So that we have a growth factor. Which one is it, and what is the growth factor? So what is a growth factor? It's a multiplier on the output to get a new output. So what is our multiplier here? 3 is the multiplier. And so is this the 1 unit growth factor of 3? 5 unit, remember? So that 5 unit, that's referring to the input. How much does the input advance when you multiply by this growth factor to get the new output? So we're a 5 unit growth factor means the input advances 5, and we multiply by that growth factor to get the output 5 units later. Okay? So now it says the 1 unit growth factor is B. The 1 unit growth factor is B, and we want to know how many people have heard the rumor after 11 hours. So look, here we have after 10 hours, 36 people know the rumor, and the 1 unit growth factor is B. So how many people know it after 11 hours? Let's see here. Hold on a second. I'm going to ask. Right here. Yes. Yeah. 36B. Why 36B? So at 10 hours we have 36. The growth factor is B. And the growth factor is? The multiplier on output to get the next output. So here's our current output, 36. Our growth factor is B, so if we multiply 36 by B, we get the next output, or 11. So that's how this all begins, okay? So that's how you get started on this problem. The rest I'll leave to you, okay? So then after 12 hours, times B squared, or times B times B. Or you could do B squared, yep. This is the idea. If B is the growth factor, if it's a 1 unit growth factor, you multiply it by output, and it gives you the new output 1 unit of input later. Okay, so let's look at the very last one. And let's do this one. So now the amount of ibuprofen in the body decreases 70% every 8 hours. So before we get started, what information can we get from that? Good, the 8-hour decay factor, right? So we can get the 8-hour decay factor, which is 0.7, right? Right. So decay factors are you don't look at the decay factor and say that's the amount that you're losing. It's the amount that you're keeping. So if your percent change is negative 70, then you're keeping 30%, and that we know that's your decay factor, the portion that you keep. Because when you multiply by 0.3, you're saying what is 0.3 of that? Or what is 30% of that? That's how much you're keeping, losing 70%. Okay, so this is the 8-hour decay factor. And so how do we get the 1-hour decay factor?
0.3 to the power of 1.
Yeah, so if we had the 1-hour decay factor and we took it to the 8th power, it would be 0.3, right? If we had the 1-hour growth factor and we multiplied it together to advanced 8 hours, it would be the same thing as multiplying by 0.3. So that means that B is 0.03 to the 1/8. Okay? So now we want the 1 day percent change. The 1 day percent change, you can't get that, so we'll talk all about this today. You cannot get 1% change directly from another percent change. Where's the 1 day percent change going to come from? What do we need first? Go ahead. Which one? We want the 1 day percent change. So it's going to come from the 1 day growth factor, yeah? It's going to come from the 1 day growth factor. So we need that. If the 1 hour growth factor is 0.3 to the 8th, then what is the 1 day growth factor? How many times would you multiply by the 1 hour growth factor to be the equivalent of 1 day? 24. You could also do the 8-hour growth factor to the third if you wanted. You could start with that, take that 0.3 cubed. It's the same thing, because it'd be 3 8-hour periods. But that's not the percent change, right? So that's just the 1 hour decay factor. So to get the percent change, what would we do? We'd subtract that from 1 to get the amount that you keep, right? And then we'd multiply by 100. So let's do the math here. It'll be easier to see. So what is the 1 day? The 1 hour growth factor or decay factor is that. That's the 1 day. Anybody got that? 0.3 to the 8th. 0.3 third. 0.3 to the third. 0.27. What is that? 0.027? That's the 1 day decay factor. What does it mean? That's the portion that of the ibuprofen that's kept in a 24-hour period. What percent? 2.7% kept every 24 hours. And that's probably high, right? By 24 hours, it's probably all gone. But we know it's going to be just a trace left, right? Just a trace left after a day. So then what's the 1 day percent change? Yeah, so it's going to be everything that we lost. If we're keeping 2.7, we're going to lose 100 minus that. 97.3? Right, percent change will be negative. Thank you. Okay, and then, so we're going to take 400. And it says how many hours will the dose provide? So if we started with 400 and did an hourly, say f of h, we wanted to set up the function for an hourly, tracking it hourly, then what would I put in here? What decay factor would I put in there? You'd use the 1 hour decay factor. If you're going to make your increment for your unit for your variable hours, then you need the 1 hour decay factor in there. Okay, so then it says use your graphing calculator, so we want to know when does this function reach 100 milligrams? And would that be x or y, the 100 milligrams? Would that be x coordinate or y coordinate? Okay, I'm hearing both. Yeah, so our x coordinate is going to be our independent variable or input. It's going to be hours, and then the output, f of h, is going to be milligrams. So if I got y equals 400 times 0.3 to the 1/8, and then all that to the x, 0. And we want to know, so am I going to set x equal 100 or y equal 100? Y, because the output is our milligrams. So this is the key point here. And it looks like 9.2115 for x. and 100 for y. And so what does that point mean? What is the 9.2115 and what is the 100? It's going to take, yeah, right. It's going to take 9.2115 hours for the dose, the amount left of milligrams in your body to be 100. So then when it drops below 100, supposedly your headache comes back, okay? And so you get 9.2115 hours. Okay, questions on this? There's a lot of important stuff in here. Changing from decay factor to percent change, changing between decay factors, using the graph to figure out a y, the x, or the input that would give you a specific output. So there's a lot of important stuff in here. Anybody have a question? So this had a lower success. Which one was the difficult one? Part C or?
Originally, when I was trying to do it a couple of times, I didn't realize it was asking for 1 day.
Oh.
I used the 1 hour part.
Okay. So you went back. You found the 1 hour percent change.
Yeah.
Yep. Okay. That's fair. Other questions before we move on? So we're going to talk a lot about percent change today. But let's just review here. Okay, we should all know this by now. So what is the centerpiece of exponential growth? What's this key element that kind of defines the whole thing for us? Was it? Okay, good. The growth factor, right? Growth or decay factor. Okay? And what is a growth factor by definition? If you had one word to describe what it was, what is it? A multiplier, right? It's a multiplier. You use it to multiply what to get what? You take a growth factor and use it to multiply by to get, right, because it's the output that's growing exponentially, right? That's the output quantity, the y value if you're graphing it, that's growing exponentially. So that's what's getting multiplied by this number to grow or decay, okay? So what stays consistent from output to output? So yes, the growth factor stays the same, but then what else stays consistent from output to output?
The initial output.
Okay, but yeah, the growth factor stays consistent, but something else. Saying that you have exponential growth is also saying that you have constant what? Percent change, right? The percent change stays the same. Multiplying by the same number means increasing or decreasing it by the same percent every time. And we remember that if you have your growth factor, that's going to be 1 plus r. What is the 1? The 1 is keeping what you had before, and then the r is the amount of change, right? So that growth factor, when you multiply by that growth factor, 1 of that growth factor, again, keeping what you had before, and then either increasing that with growth or decreasing it with a negative r. And so your percent change is your r. Okay, and when you write it this way, that's your decimal version, right? That's going to be your number between 0 and 1 or 0 and negative 1. If you want the percent, you multiply by 100. So that's all review. But this is the theme that we've been working on for the last week or so, week and a half. Okay, so let's talk about percent change. So here's our 1 unit growth factor. We'll call it B. What's if B is the 1 unit growth factor, what's the 3 unit growth factor? B cubed, all right? After 3 units, you will have multiplied by B 3 times. After 3 units, you will have multiplied by B 3 times, so that's the same as multiplying by B cubed. 10 unit growth factor? 16 unit growth factor? Okay, so those are examples. And then we saw partial unit growth factors. What's the 1/2 unit growth factor if your 1 unit growth factor is B? B to the 1/2 or to the 0.5? B to the 1/5, B to the 1/8, okay? So what's the idea here is that growth factors are directly transferable. If you have one, you can very, very quickly, like in one step, get another one. If you have the 1 unit growth factor, In one step, you can get any other growth factor of that context. All right, what about percent change? What about percent change? So given the 1 unit growth factor is B, we have the 1 unit percent change, and we know we can get any corresponding percent change from its growth factor. The question is, can we directly go between percent change? Can we directly go from one percent change to another? So let's just, and we've said no, but let's look at another example here. So suppose the 1 unit growth factor is 1.25. What's the 3 unit growth factor then? Okay, do it. So do it. And what do you got? 1.25 cubed will be a 3 unit growth factor, and that'll give you a 3 unit growth factor of 1.95. Okay, so let's look at what's the 1 unit percent change. You have 1.25 growth factor. How much? By what percent do we increase if you multiply by 1.25? 25%. The 1 is keeping what you had before. The 0.25 is the amount of increase. All right, so what do we do? So if you want the 3 unit percent change, that's 95%. Is 95% 3 times 25%? Clearly not. Clearly not. Okay? Moral of the story. Percent change is not directly transferable. Clearly, if you're growing by 25% every 1 unit, you're not growing by 75% every 1 unit. You're growing by 95% every, 3 units. 3 units. Okay, why is that? So what's happening that you don't get 75% change over 3 units? Instead, you get more. You get 95%. What's that?
It's a different output you're plugging in every time you change that output.
Right. So when you increase something by 25%, now that new amount is going to get increased by 25%. So that amount of increase the second time is greater than the amount of increase the first time. So we're not increasing by the original 25% of the original amount every time. We're always increasing by 25% of the new amount. So the percent builds on the percent, right? And so that has a cumulative effect and for growth, to make it greater than what it would have been if you just kept growing by the original 25%, right? If you just keep growing by the original 25%, then yeah, you'll have 75% after 3 units. But if you keep growing by 25% of a larger and larger number, then your cumulative effect will be then bigger than 75%. Okay. So that was I just explained that. We don't have to do that again. Okay, so what's the moral of the story? If you want to get, say, from the 1 unit percent change to the 16 unit percent change, so I've given you a map here. You just need to stay on the road. If you just stay on the road, you can do it. So how do we get from the 1 unit percent change to the 16 unit percent change? What do we do first? Yeah, we're going to follow the road, right? We're going to stay on the road. We're going to get the 1 unit growth factor. And then what are we going to do? Then we're going to take this road over here to the east, and we're going to get the 16 unit growth factor. And then, from that, 16 unit percent change. Okay, do it. Figure it out. This is 2.5%. 2.5%. Okay, is it Bryce? You're up. How'd you get started? Okay. Raise it to the power of 16. What do you think? Tell me your name right here in the purple shirt. No, purple shirt right here. Yeah. What is it? Topanga.
You have to take one away from the big pipe since you're one in what you're keeping,
Okay.
and then move your density over
Okay.
your 1 unit growth factor.
And what'd you get for that?
0.015.
So is this increase or decrease? Is it growth or decay? What's that? Growth. So our growth factor should be less than 1 or greater than 1? Greater than 1. So what would the growth factor be? You do it on the fly? 1 point. What's that? 0.025, right? 0.025. Okay, and then how do we get the 16 unit growth factor from there? Michael. Raise the power 16. And what'd you get when you did that? 1.4845? We'll say 5. Someone else get that?
Yeah.
Okay, and then one more step. So what's the 16 unit percent change? Uh-huh. Yeah, or you just, for these like these are easy. You just can read it, right? What is it? Yeah. Where can you not just read it? When you have decay, you have to do the subtraction, and then if you have growth factors greater than 1, then you can't just read it. But if you have a growth factor between 1 and 2, then you can pretty much just read the percent change right there, right? You can just read it. Okay, does it make sense? Questions? Okay. Go. If the 3 unit percent change is 79%, what's the 1/2 unit percent change? Go. Stay on the road. Stay on the road, and you can do it. Okay, Odie, you're up. Can you do it? 0.79? What do you think of that? Is that growth or decay? If you multiply by 0.79, do you get a number bigger or less? Yeah, that's going to be decay, right? We want to increase by 79%. So what should it be? Yeah, 1.79. 1.79, right? All right, and then how are we going to get? Now, if you want, if you can see directly how to get to the 1/2 unit growth factor, that's fine. Or you can go to the 1, and then from there do the 1/2, whatever you want. So you can go direct, or you get the 1 unit first, whatever. That's fine either way. So let's see. How about royal blue shirt here? Yeah, that's you.
All right, that's 1.79 to, I did a 1 unit growth factor.
Cool.
So it's 1.79 to the power of 1/3.
1/3, because it's partial. It's a 1/3 unit, right?
And then all that to the power of 1/2 to get the 1/2.
What do we think? Yep. So take the 1 unit growth factor to the 1/2 to get the 1/2 unit growth. And what did you get for that? Did you get a number?
Yeah, it's 1.109.
We agree? Okay. 1/2 unit percent change then. Yeah. So then again, we got a number between 1 and 2, so you can just read it, right? You can, when you have growth factors between 1 and 2, you can just read them. What is it? 10.9%. Anybody have a question?
What happens if it's not in between 1 and 2?
Well, it's always 1 plus r, right? You always have the 1. It's the same math. You just can't read it without doing the math, right? So what if you have 4.75? What percent increase do you have for a growth factor of 4.75? So here's the common mistake: 475% increase, and that's not right because 1 of that is what you had before. The increase is the rest. How much? 3.75. So the percent increase is 375. So the math is exactly the same as what we just did. It'd be, this is 1 plus 0.109, so the percent increase is 10.9%. It's just you don't see the number 375% isn't right in front of you. Okay? Does that answer it? Okay, the 1/5 unit percent change is negative 1.8%. So we've got decay now. 1/5 unit percent change is decaying at a rate of negative 1.8%. What's the 10 unit percent change? Make sure you get your decay factor right before you move on. So remember, decay is a little trickier. Don't go any further until you know that you've got that decay factor right. Okay, Ori, your turn. Okay. All right, but so let's get, what is the 1/5 unit growth factor? Did you get that? Zero 0.982. Agree? That's it. That's it. That's the 1/5 unit growth factor. Because if you're decreasing by 1.8%, that means you're keeping 98.2%. And so then the factor would be 0.982. Okay? Pam, you want to take over?
Okay, I went with the 1 unit percent change, so I put 0.982 to the power of 5 to get 0.913.
Okay.
And then I made that to the power of 10 and I got 0.403.
Let me hold on a sec. 0.403. Somebody else get that?
Mm-hmm.
Cool. And then?
And then I just took 1,000 and subtracted 403 and
Okay,
got
sure.
59.7%.
So, percent change is?
59.7. Oh, yeah. Negative. I always get that wrong.
-2. 80, A plus still. Okay, so then, yeah, so the 0.403, that's your multiplier for decay. Means you're keeping 40.3%, means your percent change is then the 59.7%. And that's going to be negative because it's decay. Questions? Does it make sense? All right, let's skip. I think we can do that one. Here we go. So here's a a similar example, but now I'm talking about years and quarters. So my units now are years and quarters. So the 1 year percent change is 9%. What's the 1/4 percent change? So a quarter of a year. Quarter of a year. Go. Okay. Let's see. How about, tell me your name. Courtney. How'd you do? First step.
9% is 1.09 growth factor.
Good.
And I put that to the power of 1/4.
1/4.
And I got 1.021.
1.021. Okay. Is there one more decimal place there? 217. Okay.
And that is 2.17%.
How'd you do? Perfect. 2.17% every quarter results in 9% per year, right? If something grows 2.1% in 3 months and continues on that rate of growth, it'll grow a total of 9% over the course of a year. That makes you think of what? Money, interest, right? So let's talk about that. All right, so let's hold on to that, and then let's do one more, same thing. So the 1 month would be what? The 12th unit. So 9% would be 1.09 to the 12th. Tell me. 1.09 to the 1/12th. 1.007. One more. Decimal place. 2. Percent change every month then is 0. Less than 1%, right? Less than 1% or 0.72% per month. So let's hold on to those two values. So if it's 9% every year, that corresponds to a quarterly percent of, what was it, 2.17? And that monthly percent change of 0.72%. So hold on to those two numbers. So we're going to talk about what's called APR, annual percentage rate. So talking about money, interest, and loans and debt and stuff like that. So APR, although it's called the annual percentage rate, it's different from the 1 year percent change. So it's a little different here now. Okay? So even though it sounds like, it makes it sound like it's the 1 year percent change, it's not really the 1 year percent change. So how does this work? So if you have a 1 year percent change is 9%, then we just found that the 1/4 percent change was 2.18. I guess we didn't round enough, okay? 2.18%, okay? That's what we just found. But if the APR is 9%, with what we call quarterly compounding, then the 1/4 percent change is, you actually take 9% and you divide it by 4 to get the percent change, right? That was exactly what we said not to do. We did all these examples where we said you can't go right from 1% change to another percent change. But the one time that you do that is with APR. APR, if you have the APR 9%, and you want the quarterly percent change, you divide it by 4. Okay, so APR breaks the rules. This is the one time when you would actually go from 1% change directly to another. Okay, same thing with monthly. What did we say? If the monthly percent change was 9%, or the year, if the yearly percent change is 9%. Then the 1 month percent is, we calculated 0.72%. All right, but with APR of 9%, what would the 1 month percent, how would you find the 1 month percent change if it was an APR of 9%? Just divide by 12. Just divide by 12. And you get 0.75%. Okay, so we're thinking about our money. Is it good or is it bad? So if we follow the rules of exponential growth, we would have 2.18% every quarter versus APR, we would have 2.25% every quarter. Is this good or bad?
Good in the short time.
It depends what we're doing. Are we investing our money? Then is it good or bad? It's good. We're getting a higher percent, right? Every quarter. Or are we taking out a loan? If we're taking out a loan, then is it good or bad? It's bad. We're paying a higher percentage, okay? So it depends on your situation. Okay, so here's the summary. With APR, you begin by finding the percent change per compounding period. That's this right here. By straight division. So if we were compounding by quarters, then we get the percent change of 2.25% every quarter. And if we're compounding by months, then our percent change every month is 0.75%. Okay, but then once you have that, this say quarterly percent change, now you follow the rules. Now you do exactly everything that we said before. So what's the true percent increase per year? If this is the 1 quarter percent increase, then what's the true percent increase in a year? Figure it out. So now you're going to do exactly what we did before. It's kind of like you're working back to a year using the true exponential growth. You've got the 1 quarter percent increase. You want unit, so 1 quarter unit. And you want the 1 unit percent increase. What do we expect? Is it going to be bigger or smaller than 9%? It's going to be bigger, right? It's going to be bigger because 9% per year corresponds to 2.18% per quarter. So now we have 2.25% per quarter. So the true 1 year percent change is going to be greater than 9. How are we going to do it? Let's see. Tell me your name right here. Brewer's shirt. Brandon? How are we going to do this? I've got the 1 quarter percent change, and I want the 1 unit percent change. So that's the percent change. I'm going to raise this to the.
Convert that to a decimal.
Okay, so it's.
0.0225.
Okay.
And then raise that to 1/4.
Is this growth or decay?
Oh, plus 1.
Yep.
So 1.02.
So this is what? This is the 1 quarter unit growth factor. And then what?
Raise that to 1.
This is the 1 quarter unit, and we want the 1 unit.
Oh.
So the 4th, right? Anybody got it?
0.093.
One more. The true 1 year percent change then is 9.31%. So this is the procedure we did on that. Remember, we follow the road. Percent change to the corresponding growth factor to corresponding growth factor. To percent change. So at 9% APR with quarterly compounding is really your whatever, if it's loan or if it's your investment, is the percent rate is the true percent rate is 9.31%. Doesn't make sense. All right, so do it for monthly. So figure out what is the, if we compound monthly and we get this 0.75%, 1 month percent change, then what is the true annual percent change? Again, we're thinking it's going to be greater than 9%, a little bit greater than 9%. And I'll take attendance. Oh, did that. Yes, sir. Did you get started?
Yeah.
Tell me.
I did 1.0.
How do you do on this monthly growth factor? Good, right? Yeah, that's 0.75%. All right, then to get the, what's that called? Is it a rate? You're doing the right thing, but what do we call that? What is that? That's the annual growth factor. So this is the monthly growth factor, annual growth factor. What'd you get for that? 0.0938. Therefore? Okay, so an APR of 9% compounded monthly means that monthly you actually make 0.75%. And then that corresponds to a true annual percent increase of 9.38%. So this is the real percent increase, actual. When you have APR of 9% compounded monthly. Again, if this is an investment, good for us. We just made an additional 0.38% per year. If it's a loan, then we're paying more than 9% per year, right? And so they passed a federal law a long time ago that when you sign paperwork for a car loan or for a home loan, there's a page and it's called, the disclosure. The disclosure, they're disclosing to you that 9% with monthly compounding means you're actually paying a higher rate. So you sign this form that says you understand that you're not paying 9% per year, you're paying 9.38% per year. And that's the APR disclosure form. Okay? What's that? Because I don't know how it originated. But this is how it happens. They call out an APR percent, and then they compound it, and then they do a straight division. So this is just what they do, and I don't know how it came about. But when you do this, your actual percent per year will be greater than this number called the APR. But I don't know the origin of this system. I don't know it. But it's still our common practice. Okay, so I'll put you to work on these while I take attendance. So, and so that number, the true rate of return, is called the APY. So APR is this number that you start by dividing based on compounding. And then when you work back to figure the real true percent change, that's called the APY. So those two numbers you just found, the 9.2 something and the 9.38, those were called APY, annual percent yield, the actual percent increase. So here are some practice problems, and I'll take attendance. Homework for Monday along with web work, and then quiz and recitation. Yeah.
For the first step for this, would you divide like 7.5% divide by 2
By
first,
2.
and then solve from there?
And then you got the percent increase, and then you go back to a year
Okay.
the normal way, right?
Yeah.
Yep.
Why is the title called exponent?
Well, it has to do with the word exponent, right?
Yeah.
So, why do we have exponents?
Yeah.
What are they for? What do they do?
Yeah, I thought I had to ask you. But, the exponent is the time of the growth factor.
No, but what does an exponent do? So if you have like 3 to the 8th, what does the exponent do? What does that mean?
That means like 3, like
Yeah, what does it mean?
3, 3.
Right, and what does that have to do with exponential growth? 3 times 3 times 3 times 3 times 3. So what? So that's what an exponent means, which means 3 times 3 times 3 times 3 times 3. And so then, how does that relate to the principle of it?
Like it has a constant growth factor.
Constant multiplier, right? So exponent is representing repeated multiplication, and that's exactly what exponential growth is. We keep multiplying by the same number over and over again.
All right.
Does it make sense?
Yeah.
When will you have the homework up by?
This morning.
Okay.
Yeah.
I wanted to go over it and work on it right now.
I'll try for half an hour, okay?
Awesome.
I'm gonna miss my recitation class,
Okay.
so would I make up the quiz or just how would I go about that?
Yeah, you could. Why are you missing?
I have a leadership camp this weekend and I leave like right now.
Okay, yeah. So you could come to
The Monday?
Tuesday office hours is fine, or you can come to Monday. You want to go to Monday recitation?
Yeah, if I don't know what time that's at.
I think it's the same time place.
Is it?
You just ask LP. LP's same classroom on Monday as Friday for recitation, same time and place. Can he come? He can meet today. He'll come Monday. Okay, yeah,
Okay.
it's great.
Alright, thank you.
Sure.
So is it up right now or no, not yet?
The 4%
Yeah, so we can-
weekly. So what do you do? 4% first and 4%. No, the first thing you have to do is get the weekly percent change.
No, because I was just listening. I was like, okay.
This is an annual percent
Pretty much
rate.
same
Oh.
question.
So the first thing you need to do is get the weekly percent rate.
Okay, so
What would you do?
so
Thanks, Elby.
raise it to the power of 4.
No, remember. So with APR and compounding, the first thing you always do is divide.
Okay.
I think.
So if it's weekly, the weekly percent rate will be 4 divided by 52.
Okay.
That's like the one time when you do that. It's the one time you get 1% from another by straight division. You don't ever do that any other time except with APR. So you're going to do 4% divided by 52.
Okay. So with all these you divide first.
Yes, you divide
and then-
first, like we did with the other ones.
Okay. All right. Thank you.
Divide first, and then from there you follow. You stick to true exponential growth.
Okay.
Yep.
But I guess in the case of like the semi-annual, so you could just, I mean, technically you just multiply by 2.
Divide by 2. You need to get the semi-annual or the 6-month rate first. Your 6-month rate will
Okay,
be.
so it's not, okay, so the APR isn't, when you say compound semi-annually, that doesn't mean that it's already at the semi-annual rate.
No, this is an APR annual.
Yeah.
It's an annual percentage rate.
Okay,
So
That's-
that correspond, but it's not your percent. It's not your annual yield.
Right.
But it's an annual number.
okay, that's it, that was
APR annual. So you're going to first get the semi-annual
which is
true
divide by
rate.
2,
Divide by
and
2.
Then you go use the growth.
Then you use the exponential growth.
So then with the 4%, you just divide by
Divide by
12, then divide by 4
not
again.
12. Oh, No, 52 weeks
Yeah,
in a year.
52, yeah.
So divide by 52.
Yeah, because I have trouble big numbers in my head. So. And then the 21.9 would be divided by 12. and
Divide
then
by 12.
And then daily would be 365.
Divide by 365 first.
Okay.
That gives you the per period rate.
Mhm.
From that, you can get the.
Okay.
Yep.
All right, 2 easy.
So when you do 4% divided by 52, you get that number, and then you
That times 6.
I forgot. Do you add 1? And then you do it to the power of.
Yeah. So if you just keep trying to focus on what every number means, then it will be easier. So when you take 4 divided by 52, what are you getting? You're getting the weekly percent rate. So what do you need if you want to get a different percent rate? What do you need from that?
To put it to the 52nd power again, because
No, you need in order to go from one percentage rate to another, you need growth factors.
Oh, growth factor. That's right. That's right.
So you got the
So
percent.
then you add 1 to this, and that
You're
makes
gonna
it
add a
growth
1. That'll be the 1 week growth factor, and now you can make your transfer between time
Now
frames.
you make it 52. Okay.
To the
Thank you.
52nd is the 1 year growth factor.
That's
and-
all.
yeah.
I'm assuming they will have to
Oh, okay.
like these questions, or later on with there,
Yeah, sure. These are better. This is.
or no since.
Yeah.
These here.
Just finish investigation 5.
Okay.
Yeah, that's good. That's real good stuff.
Right. So from
Just investigation 5. Yeah.
Okay.
And then if they're done early, and you got the quizzes printed out.
Right. Yeah. For that bonus grade,
Okay.
like for the right every